Okay, so now I think you can hear me. Okay, nice. So, good evening, all. Welcome to today's class. Okay, so happy evening. So yesterday, so all of you, I believe, wrote the test. Okay, so uh, how was the test? You can let me know in the chat. Okay, about the gravitation. Okay, so what was the difficulty level? You solve all the questions, or you found it difficult, or you could have you know got much more marks. If you are expecting more than 15, okay, and you think that you have done well, you can click on the yes icon. Okay, because whatever questions that we had given, okay, expect a little same or little easy level paper for your school exam. Okay, more or less. Okay, more or less. So depends on which school teacher is making the paper, but more or less it will be of same level. Okay, so do not worry, it will not be so tough also. If you have studied from the textbook, if you have gone through the notes, okay, then this should be fine. Okay, so practice more questions. That's the only suggestion that I have. Since this is physics, you cannot, you know, by heart things. You need to understand things and try to solve much more numericals. Okay, so very good. So that was about the gravitation. Okay, but as I told you, so there are few extra topics. Okay, so that I will be today doing, because if you remember, so I had written about some extra things, okay, which I told that I would be covering. Okay, so in this update, you can see that, so a gravitation test over. Okay, but look at the another update. Okay, so that is on Sunday, October 25. Okay, so on Sunday, October 25. Okay, so you have the science major test. Okay, the second major test. So all the chapters, okay, all the chapters, so we have completed. Okay, you just have to revise that, and that will be our major test. So what are the topics, what are the topics that will be coming in this major test? So I have made it here in this box. Okay, so force and laws of motion, which we have completed long back. So tissues, biology chapter, and next is matter around the sphere, the chemistry chapter, and again gravitation till what we have prepared for. Okay, so what topics were there in the yesterday's test? Same. Okay, so only these four chapters for your science major test, second major test. So which is on Sunday, October 25. You have couple of weeks left. You have easily around 13 days. So practice, just revise things. We have already written test of all these chapters. Okay, so that is the update I wanted to show. Okay, so next, as you can see, so I've written some extra topics, so which I told I'll be doing later. That later is today itself. Okay, so that is, I want to cover centripetal force versus centrifugal force. Next, the basics of Kepler's laws, as well as this escape velocity. Okay, so these are the things we'll just quickly cover it off, and next we'll start a new lesson today. What is that new lesson? I will show you the clue, and hopefully you will be able to identify the next chapter, the new chapter that I'll be starting today. Okay, fresh week, a fresh day, and a fresh chapter. Which chapter is that? We will see later. Okay, so now on your screen, so let us start today's class with this thinking question. So what is the thinking question? So I'm going to show you the thinking question. So a few years back, had launched this amazing project, okay, so of sending the Tesla Roadster to Mars. Okay, how many of you know this? You can click on the yes icon if you're aware of this fact. Okay, that there is a bloody car uh, going round and round the Mars, is orbiting the Mars. Okay, if you remember this, okay, you can uh, click on the yes icon. Okay, and you can let me know in the chat also. Okay, so yes remembers. Okay, so very nice. Okay, so now after you watch the video, I'm going to ask one question. Okay, so let us see if you're able to answer that question. Okay, so but this project is 2 years old, almost 2 years old. So this happened in way back in 2018. So watch the video, and then I'm going to ask you a question about this project. Okay, or this SpaceX mission. Okay, what is that question? I'll ask after you watch the video. Okay, so very nice. So that was the video. Okay, so very nice. Okay, so very nice mission. Okay, so where they experimented something, okay, which is very unusual. Okay, so now, as you saw the video, the question here is, where is that bloody car? Okay, in the space, because we have seen this happen 2 years ago. Okay, in 2018. Okay, the car was launched in the orbit of the Mars. But what is it doing now? It's been 2 years. So what might have happened to the car? Did the car run out of the fuel, or did something happen to the car? Okay, so is it still orbiting around the Mars, or uh, something else happened? So we will see what happened to this car. Okay, because they have found out the result, or the output, whether the car is still there or not, and they have shared the information. So what is that? I'm going to tell you at the end of this class. Okay, so that was the question about this car. Is it still there? If it is still there, what is its nature or the condition? Is it ruined, or is it perfectly fine? Okay, so we will see that later. Okay, but first, so I want to show you about, I want to tell you about this extra topics. As I've said, this is extra topic. It's not going to come for your exam. It is just a little bit advanced, for just for your knowledge or information. Okay, so I'm just going to write here extra topics. Okay, so the first one, what we'll be heading towards, is the escape velocity. Because as you've seen in the video, okay, they are clearly mentioned that this Falcon Heavy, okay, so there was a clear chance of this monstrous rocket just blowing up and becoming an unsuccessful project. Okay, but that did not happen. So if you notice here, okay, so whenever you launch, okay, so any rocket, okay, whether it is the most powerful rocket, or it's just a normal simple rocket, okay, so you must have seen that there's a lot of energy, okay, so which is utilized for sending the rocket, okay, because it has to get the speed, the required velocity, such that it can overcome the gravitational force, okay, gravitational force of the Earth. Okay, so now we will see, as you saw in the rocket launch, okay, what should be that velocity to escape the gravitational force. Okay, so I'll just quickly tell you the definition. The escape velocity is the minimum velocity or the minimum speed in the proper direction. Okay, it is the velocity. So I'll write here minimum, okay, minimum, not maximum, minimum velocity required to overcome the force of the earth. Okay, it is the velocity, minimum velocity required for any free object. Okay, so not, okay, so not under the influence of any other force or something. Okay, so any free object, okay, any free object to escape, okay, to escape the gravitational, to escape the gravitational influence of earth or any celestial body, if you're talking about in moon or Mars or something else. Okay, so since we're talking about escape velocity, okay, so on earth, okay, escape velocity related to earth. Okay, so if you're talking about escape velocity in moon, of course the value is going to be different. If you talk about escape velocity on Mars, the value is different. Okay, so depending on the celestial body, they have different escape velocity. So what is the formula? You can definitely calculate this. Okay, so when you come to 11th standard, third chapter, so you will learn about in detail in the mechanics. Okay, but I'll just quickly tell you only the part. I'll not go deep into the derivation part. Okay, so if you do this, then you will get the escape velocity of object on Earth. Okay, so that is, I'm just going to take the square root. Okay, so 2g mass of the Earth divided by radius of the Earth. Okay, so if you do this, you will notice that this velocity is the escape velocity, that is 11.2 kilometer per second. Okay, so that is the velocity with which the object should be pushed such that it can go to the space. Otherwise, it will again fall down. Okay, so this is our first topic. So that is the escape velocity. Okay, so I again tell you, this won't come in the exam. This is just an extra topic. That's all. Okay, I'll just quickly visit few extra things so that you just have little bit of more knowledge. Okay, so this is your escape velocity. So you substitute the values, okay, and you will realize that it will come around 11.2 kilometer per second. Okay, so now, so moving ahead, okay, the second extra topic, so what I'll be doing is the much awaited centripetal force versus centrifugal force. Okay, so we'll see the difference between the centripetal force versus the centrifugal force. Okay, so that is the second extra topic. Okay, so that I'll be quickly covering. So on your screen now, first I will show you the video. Notice the video carefully and it will help you in easy understanding of the topic. Okay.
Students tie a small piece of stone with a...
This is a magnet. Okay, that is different. Okay, so over here, so let us just quickly go back and see what happened. Okay, so the force applied by your hand in rotating the stone, that is your centripetal force. Okay, but the stone which is, having this influence or experiencing the outward, because at any point of time, if you cut the string, it would get ejected and it will move in the tangential position. So at every point of time, it is also experiencing an equivalent opposite outward force. Okay, that outward force, you call it as centrifugal force. That's all. Okay, if you technically see, centrifugal force is a pseudo force, non-real. It is not a real force. It is a pseudo force. I hope you know what is a pseudo. Okay, it is a non-real force, that is an inertia. Okay, centrifugal is actually an inertia. Okay, so it is not actually a real force. Okay, it is the object experiencing. Okay, experience. It is not real. Okay, it is pseudo. Okay, it experiences an inertia. You have learned about inertia in Newton's first law of motion. Okay, so it experiences an inertia. Okay, in the outward direction, which we call it as centrifugal. That's all. Okay, that's the only thing. Okay, the hero here is the centripetal force. Centrifugal force, it is just a side actor. Okay, it's not a real, it's a side actor, no important role, side acting. Okay, it is a pseudo, false, not a real force. It is just an inertia. Understand? Okay, it is just an inertia. Understand? I hope you know what is an inertia. We have learned force and laws of motion already. So I'm going to write this in form of points. Okay, so that you will understand. Okay, so the first thing, as we know about the centripetal force, okay, so this is my center seeking force. Simple, straightforward. Okay, so about my centrifugal force, So this is moving away from center. Okay, the direction is moving away from the center. Okay, whereas in centripetal, the direction is towards the center. Okay, the next thing, it is a real force acting towards the center. Towards the center. Its direction is towards the center. Okay, the real force acting towards the center. Whereas my centrifugal force is a pseudo force, non-real. Okay, non-real. It is not at all real. It doesn't have its own existence. Only when you have centripetal force, you can notice the pseudo force or a non-real force. It is not a force, it is an inertia. Okay, it is just an inertia effect. That's all. Okay, you feel like experiencing the outward force. You feel like you feel like it's not a real force. Okay, it is just a pseudo force. You have that only in the presence of centripetal. If centripetal is not there, then centrifugal has no existence. Okay, so if you want to understand in the form of diagram, so I can do one diagram and show you. Okay, so notice this diagram. So this is my direction of velocity. Okay, so now my centripetal force is acting towards the center, that is CP is my centripetal force. Now, what is the centrifugal? I'm going to do the same diagram. Notice carefully. Okay, so this centrifugal, I'm going to show you the same diagram. Okay, same diagram. This is my velocity. Okay, now comes my centrifugal force like this. Okay, but since this is not a real force, I'm going to use the dotted line. This is CF, exactly in the opposite direction of CP. CP is centripetal force. Exactly in the opposite direction. You have the dotted line. That is your pseudo force, non-real. It's just an inertia. Okay, it is just an inertia. Okay, so that is your centrifugal force. So I'll just write one more point. Okay, and then we can move to the next topic. Okay, so one more point, so which will help you in understanding it better. Okay, so this centripetal force ensures that the object has this circular motion or is moving in the circular path. Okay, right here. So the force which keep the object moving in circular path or moving in circular motion. Okay, so this is your centripetal force, the hero. Okay, now comes the side actor, not an important role. Okay, so that is your centrifugal. So I will write here the object moving in the circular path only. You don't have centrifugal in any other type. Only in a circular motion, you have centrifugal. Okay, the object moving in a circular path experiences, okay, experiences an outward, okay, experiences an outward push, okay, experiences an outward push. Not exactly that, it is inertia. That's all. Okay, an outward push, which is inertia, or you can just call it as the, if you do not remember, okay, it's the tendency to move away from the center. Okay, so this tendency or this experiencing part, you call it as centrifugal. Technically, it is not a force. Okay, it is just an inertia which is experienced by the object. So if you understood this, you can click on the yes icon. So real quick, so that I can move to the next extra topic. Okay. As I said, it has the same, okay, it has the same, what you call same line trajectory, but it is in the opposite direction, exactly the opposite direction. Okay. The direction opposite to CP is your CF. Okay. Is your CF. You can look at the diagram. So I have done the diagram. Okay, I've done the diagram. You can look at the direction, the dotted line. It is exactly in the opposite direction. Okay, the outward direction. Okay, and more about this, as I said, again in the 11th standard, you will have revisiting of all the topics, so which you will see in detail, okay, in depth, okay, about the mechanics. Okay, so this is just an inertia. Please understand, this is just then why do we call it as a force? People, they just simply call random things. So doesn't mean everything is true according to science. We have a very technical definition. So centrifugal is a non-real, it's a pseudo non-real force. Okay, so hence we just put that quantity as force, but it's not actually a force, it is just an inertia. Okay, it is just an inertia. Okay, an effect of inertia, in the opposite direction as your centripetal. Okay, an inertia in the opposite direction of your centripetal. Okay, so more about the non-real things, the pseudo force, everything, as I said, you do not have any idea about that. 11th standard, please wait. The physics in 11th standard will open your eyes and will also enlighten you. Okay, so wait for 11th standard if you want to know extra details. Okay, so I'm moving on to my next topic, that is Kepler's law. Okay, so Kepler had given few laws, 3 laws about the planetary motion. Okay, so what are those 3 Kepler's laws? So I will not do the derivation part at any point. I will only stick to the law. That's all. No derivation, nothing. You will see that in your 11th standard. I'll just mention the laws. Okay, so what are the 3 laws on your screen now? So I'll show you the video. Notice this animation properly, and we'll talk about each and every law in detail. Deviation. So the planets are actually not having a circular orbit. Okay, the planets revolving around the sun, so they have an orbit in the shape of an ellipse. So what is an ellipse? Okay, so you will learn in mathematics about an ellipse in detail. Okay, so ellipse is a structure, okay, or ellipse is a particular path in which you have 2 center. Circle has only single center, but ellipse has 2 center. Okay, we call them as foci. Okay, one focus and another focus, 2 focus. So you call it as foci is the plural. Okay, so the sun is at one of the centers of the ellipse. Okay, so this is the first Kepler's law. Okay, so he clearly mentioned that the orbit is not circular, it is in fact ellipse. It is in the shape of the ellipse where sun is at the one of the center. That's the first law. Okay, then he little bit also told, okay, a little bit also told about the speed and everything. Okay, so whenever the planet is closest to the sun, okay, so that it travels faster. When it is away from the sun, that is in the aphelion part, it travels slowly. Okay, so that is another thing. Okay, so over here, so you need to notice that why it is an ellipse, because there are a lot of factors involved. Okay, first of all, nothing is perfect. Okay, so it is not a perfect sphere anymore. Okay, the planets are no longer a perfect sphere, or the trajectory is also no longer perfect. Okay, so and everything so matters, and because of that, you do not have a perfect sphere or do not have a perfect circular orbit. Okay, the idealistic thing is only an idea. It's not real. Okay, so people have unrealistic expectations. Okay, they think that every student should be a topper. Your parents have unrealistic expectations. They want you to be the all India topper. Okay, but everybody cannot be an all India topper because the reality is different. Here also the same thing. Okay, the planets are supposed to have a circular orbit, but it won't. Okay, it won't. The reality is different. The reality is an ellipse. Okay, it has the orbit in the shape of an ellipse, and circle is at the one of the center of an ellipse. Okay, so before you forget, so I'll just quickly write it down. Okay, Kepler's first law. Okay, so what is the first law? So as you saw, the orbit, okay, the orbit of a planet is an ellipse with sun at one of its foci, with sun at one of its foci. Okay, so where the sun is present at one of its foci. Okay, so an ellipse is like this. Okay, it has two centers, and the sun occupies one of the centers. Okay, this is your center and this is your F2. Okay, so this is your sun. Okay, so this is our law 1. So next, let's go to law 2. Interesting. So law 2 is about the distances covered and the time taken, because now we know that planet is revolving around the sun in the shape of an ellipse. The orbit is an elliptical orbit. What about the distance? How much distance is it covered in how much time? Okay, that is the second law. Amazing second law. Look at the conclusion. Beautiful. You will fall in love with Kepler, the way he came to the conclusion. Okay, but of course, we will not see everything in detail. 11th standard, we will do that. Now, I'll just give an idea. That's all. So moving ahead, the second law. So what is the second law? So let's look at the second law.
The line joining the planet to the sun sweeps out equal areas in equal times as the planet travels around the ellipse. This is also known as the law of equal areas. Suppose a planet takes 1 day to travel from point A to B. During this day, an imaginary line from the sun to the planet will sweep out an area. The same area will be swept every day. Here, the areas A1 and A2 are equal and the time T1 and T2 are also equal. Kepler's third law.
Okay, so as I said, so before moving on, okay, before moving on to the third law, okay, so carefully notice what is happening. Okay, so over here, so since this is an elliptical orbit, okay, so you can clearly look at how the planet is revolving around the sun. Okay, the distance covered by the planet. Okay, so if you notice, suppose it is covering A2 distance. Okay, so compared to that, if you can trace out, okay, if you can trace out with proper calculations, of course, if you can trace out on the other side of the sun, how much would the same planet would cover? Okay, it's an idea. Okay, how much it would cover on the other side of the sun. So that will be what A1. Okay, so they are telling that the area A1 is equal to area A2, and the time T1 taken to cover area 1 will also be equal to time T2, that is the time taken to cover A2. Okay, I will also draw the diagram and I'll show you what exactly is happening. Okay, so that's why I told you this is a beautiful conclusion. So you want to know more about this? 11th standard is waiting for you. Come to 11th standard. So you will see everything in detail, whether you like it or not. Okay, so now it is just an concept. That's all. As I told, it's just an extra thing that I'm doing. Okay, so I write the second law. Okay, so as the planet travels around its elliptical orbit. Its elliptical orbit. It sweeps or it covers equal areas in equal intervals of time. In equal intervals of time. Okay. So here, so as I said, I'm going to do the diagram and show it to you. If this is the ellipse, okay, if this is the ellipse, so it has two centers. Okay, the ellipse has two centers. The center itself, you call it as the focus. Okay, the center itself, you call it as focus, F1 and F2. Okay, and in one of the centers or in one of the focus, you have your sun. Okay, you have your sun in one of the focus. Okay, or one of the center. Okay, so now when the planet, as you saw, is over here. So suppose, okay, it covered, suppose it covered, so this much distance, just assume, okay, suppose this much distance it covered. Okay, so green color. So now what I'm going to do is that, okay, I'm going to mark another. Okay, I'm going to mark another. Okay, and I will mention the time also here. So this is my time T2 and this is my time T1. Okay, so it tells that the area, okay, with triangle, the green color triangle area. Okay, so area of whatever the green color triangle, I just name it as X, Y, Z. Okay, the area of X, Y, Z is equal to the area, I'll just mention this as ABC, area ABC. Okay, so the area, the green color, okay, area 1 is equal to this area 2. All of them, they are equal. Okay, because since it is an ellipse, so you should know the properties of an ellipse, unfortunately, which you haven't learned, which you will not learn till 11th standard mathematics, because in mathematics, you will learn about the different shapes, about the hyperbola, parabola, ellipse, everything in 11th standard. And then you will understand the properties. Once you know the properties, then you would appreciate Kepler. What a conclusion it was. Okay, that it sweeps equal areas in equal amounts of time. So that is the beauty. Okay, the time taken is the same. Okay, if you look in your textbook, okay, there's a blue, not blue, there's a brown box in which it is given. If you're not sure, so I will show you. But that is just an extra information, not for examination point of view. So hence, I also just kept it as the extra information. Okay, so if you look at your textbook, if you're curious enough, you can definitely read it. Okay, but it is not for the examination point of view. Okay, so this is your Kepler's law, which they have given over here. And I'm just doing that real quick because I just want you to be excited, but I don't want you to get confused with the main topic. Okay, because I want you to focus on the main topic first. That is our preliminary focus. Okay, so over here, these three laws is what I am showing it to you. Okay, so if you want, you can of course read this. You can get excited, but you will know in detail the exact reason. 11th standard, once you know everything. Okay, so that is our second law, which I've just told in brief. So moving ahead, the last law. Okay, this last law helped Newton to have his gravitational, universal law of gravitation, is all because of Kepler's third law. The idea that Newton got was from Kepler's third law. So you call this as the inverse square rule. Okay, so I'm going to share my screen. I'm going to show you the video first. Okay, notice this. If you do not understand, no problem. So you will understand in detail in 11th standard. So this is just an extra topic that I am doing. Okay, so on your screen now, so let's see the last law. So, they've just ended it abruptly. Okay, but anyways, so in the third law, what is happening here is that, okay, they're trying to relate the terms. Okay, they're trying to relate the time period. Okay, so with the distance of that from the sun, that is the semi-major axis. Okay, so now, so they're trying to relate the time as well as the radius. Okay, so you can consider that as the semi-major axis or the distance of the planet from the sun. Okay, so now they are comparing two planets. Okay, so the two planets you can see over there. Okay, so planet 1 and next planet 2. Okay, planet 1 having radius r1 and time t1. Okay, planet 2 having radius of the orbit, of course. Okay, so radius r2 and time t2. Okay, so if you compare them, okay, so you get this beautiful relation. Okay, so that is t square is proportional to r cube, or the other way around, r cube is proportional to t square. Okay, so now slightly move forward.
Is directly proportional to r cube. So t square.
Okay, so the t square by r cube. Okay, so you see that you will obtain a Kepler's constant. Okay, so what is this Kepler's constant? Okay, so we will definitely figure that out when we are doing the derivation. Okay, but in the derivation, you should first of all know something called omega. Okay, so that is your angular velocity and everything. So in the textbook, if you actually see, so they have just taken it in the form of v square. Okay, so they have just taken in the form of v square divided by r. Okay, and they're trying to relate it to the force. Okay, in a simple way. Okay, but if you actually see the real derivation, okay, in terms of the omega, okay, so that is your angular velocity. Okay, then you would be able to appreciate, okay, the value of the Kepler's constant. Okay, so but anyways, so I will just leave it over here. Okay, so you need to understand that the Kepler's third law, okay, using this, so Newton was able to bring out the inverse square law. Okay, so you want to know in detail. Okay, so you can see over here in the textbook. So they have at least put an effort. Okay, so to tell you in the minimum terms. Okay, like this. Okay, so but of course they don't do justice because you do not know first of all what is an omega. So they're trying to figure this out without calculating the omega. It's all just a proportionality. Okay, there's no equal to symbol because they cannot do it with the help of omega. But you do not know what is an omega, so they cannot help it. So that is why. So they've just done this in a very simple way. Go through this. If you understand, fantastic. If you do not understand, no problem. 11th standard you will learn. Okay, so but I will definitely try to tell you. So what is happening over here? The force that you see here. Okay, so this force is your centripetal force. Okay, this force what you can see here. Okay, this is your centripetal force. Okay, centripetal force actually has the formula mv square by r. But they're not considering the mass. It's just the proportionality symbol. So they are trying to relate this with what Kepler had showed us. Okay, so but they need an omega. So they're taking omega as 2 pi r divided by t. Okay, so over here you can see that they're taking this omega as 2 pi r divided by t. But they're taking that as velocity itself. Because they cannot show omega. If they show omega, you do not understand. And you do not understand, then you will not read only. Okay, so hence they're just taking it as in terms of velocity v itself. Okay, and they're trying to relate the radius and the time. Okay, so that is, they're showing this v square proportional to r square by t square. Okay, so once you write that with a small modification, so they are multiplying 1 by r. That is the beauty. They're multiplying both the numerator and the denominator by r. So that is why you see you get r cube by t square. Okay, but in the denominator you have this extra r. Okay, such that they want to remove this term in the form of Kepler's constant. Okay, and then you get this relation that is v square is inversely proportional to 1 by r. Okay, so the v square is inversely proportional to 1 by r. Okay, And that V square is nothing but my centripetal force itself. F is equal to V square by R in the beginning. Okay, if you did not understand, no problem. Okay, so maybe in the foundation class, okay, so I can, have the luxury and the time to focus more on this. Okay, because my main motive is not to confuse you unnecessarily. Okay, so you want to know more about this. Okay, so when we start our SAT, okay, in our foundation class, so then I have lot of time to tell you everything in detail. Okay, so in the foundation class, okay, such that you know how wonderful this equation was. And Newton gave the satisfactory explanation for the Kepler's third law. Kepler himself could not give the explanation because he could not see the application part. Okay, but anyways, so I will just not confuse you. Okay, so that was just an extra thing. Okay, so I'll just write the law. Okay, and I leave it over here. Okay, so in the foundation class, we can come back to this topic in detail and we can see exactly how the derivation works. Okay, so because the foundation class, I have a lot of time. Okay, so the law number 3. So all I will write here is the ratio. Okay, the ratio that you saw. Okay, the R and the T ratio. I'm just going to write that. The ratio of squares of the time period, okay, which the planet takes to revolve around the sun is equal to the ratio of the cube of the semi-major axis, that is the radius of the semi-major axis. So that is, I'm just going to mention this. That is T square proportional to R cube. Okay, so if you remove the proportionality constant, then you will be having your Kepler's constant. Okay, so if you remove that proportionality, then you will have the Kepler's constant. Okay, so which we will see in the foundation class. Okay, I don't want to unnecessarily deviate from the topic because I want to start a new chapter. Okay, but these are some things that I really wanted to tell you. Okay, so I just want to end it. Okay, so with this last term, okay, so that is the last extra topic. Okay, so that is how height affects the G. Okay, so the height or the depth affecting our acceleration due to gravity. So can you tell me what is the value of G? Okay, the small g. You can type in the value of the small g. So what do you think is the value of small g? So very nice. Okay, the value of G is 9.8. Okay, fantastic. So G is 9.8 meter per second square on the surface of Earth. Okay, so on the surface of Earth, the value is 9.8 G. Suppose, imagine this condition. Okay, so where I am on a aeroplane. That is an aeroplane. Okay, so the green color what I did is an aeroplane. So imagine, I know my drawing skills is horrible, but your imagination skills is fantastic. You can imagine I'm going on a flight to very in the sky. Okay, only I am going. Nobody else is there. I am the pilot. Okay, I'm the pilot. Only I am going. Okay, so this flight, assume this is at 40 kilometer above surface of the Earth. Do you think the G value will be the same? Do you still think that G is 9.8? What do you think? Okay, if you think G value is still going to be the same, the acceleration, if I fall, don't ask me how. If I want to fall, okay, if I want to jump, okay, from the plane for no reason, okay, just assume, no parachute, okay, I just want to die. Okay, if I'm just jumping from the plane, okay, so jumping from the plane, Okay, so do you think the value of G is still going to be the 9.8? If you think it is yes, okay, so then you click on the yes icon. If you think it's no, then you can click on the no icon. Okay, so let us see your opinion. Okay, so as most of you have told, the value of G is not going to be the same. The value of G is going to affect badly. Okay, so as this 40 kilometers is very less, if I go very, very far away, so from 400 kilometer or some 100 kilometer, okay, or something, then the value of G is definitely going to get affected. Okay, because only from here till here is my radius of the earth. Okay, then after that I have this extra. Okay, so that is, I'm going to consider this as my h, okay, height h. So how will my G change? So I will just give you the formula. Okay, so derivation, I do not have time, so we will maybe do the derivation in the foundation class. Okay, so now the value of G at this height h, okay, that is my new G, gh. Okay, so that height, so my value of G is gonna be like this. Okay, so that is the original G multiplied with 1 minus 2h divided by RE. Okay, so if you substitute the values, okay, you will definitely find the value of the new gravitation acceleration due to gravity. Okay, can you quickly just do this and tell me what should be the new acceleration due to gravity? Okay, at the height 40 kilometer. Okay, if you can just quickly substitute. Okay, if you can quickly substitute 1 minus 2 into 40. So divide by this is 6,400 kilometer. I'm just keeping this in kilometer. Okay. No, I have to keep it in meters. If you calculate this, okay, so can you tell me what do you think will be my value? You can just quickly calculate, okay, so and let me know. So what should be the value? Okay, so meanwhile, I will also try to just quickly solve. So this is 9.8. That's 2 into 40 divided by, so 6,400 minus 80. Okay, so if you can just quickly help, okay, you can just type and let me know what should be the value. Okay, if you find the value, then that is our new acceleration due to gravity at a height very high from our earth. Okay, that is at 40 kilometer. Okay, I would experience, okay, so this much acceleration due to gravity. You can quickly type in the chat and let me know. Okay, so what do you think should be the answer? Okay, so this is my new acceleration due to gravity at the height. Okay, at the new height. So very nice. Okay, yes, has calculated along with the fantastic. Thank you so much. Okay, I'm just going to round it off to 9.67. Okay, so meter per second square. So you see, definitely the value of G will get affected. Okay, the value of G decreases. So I can write here this conclusion. Okay, the G decreases if the height above the earth surface increases. Okay, if you go very high on the top, okay, so then of course the value of G will decrease. Okay, and the equation is given like this. So of course you will see this derivation again in 11th standard, but I'm definitely going to show you in the foundation class. Okay, so this is your acceleration due to gravity, okay, being affected because of the height. Okay, so now what about the depth? Okay, suppose I decided to go inside the earth. Okay, don't ask me why. I decided, that's all. I decide lot of things. Okay, so I decided to go inside the earth. Okay, so if this is the earth like this, I'll draw the diagram. Okay, and I made one vehicle, okay, or something. So now I went deep inside. I am here inside now. That blue color, that is me. Don't ask me how I went. I went, that's all. Okay, I went inside. So I am over here. Okay, so this is the earth. Okay, and this is my depth. Okay, so sorry, depth. This is the depth. Okay, so D is depth. I went so deep inside, almost close to the radius of the earth. Don't ask how I went. I just went. That's all. Okay. So what do you think should happen to my, acceleration due to gravity? I'll just end this. Okay. So I'll just finish this and then we can go for the quiz. Okay. So again, so you have the formula. Okay. At the depth, okay, the acceleration due to gravity deep inside the earth is given by this formula like this. Okay, so now, so if this depth is again, so suppose I went 4,000 kilometer. Somehow I went, okay, inside the crane. I dug inside the earth. I wanted to find gold, diamond. Okay, so I was very much curious. I kept on going inside some 4,000 kilometers. Somehow I went. Okay, so deep inside the earth. Okay, so how do you think the G will be different? Okay, so you can definitely please count and let me know. Okay, so we will definitely see this again. So tomorrow, so I've given you the formula. Okay, so please solve this and tell me. So what will be your new value of G is gonna be? Okay, so it is equal to the original acceleration due to gravity into 1 minus d divided by re. Okay, over here I have told the depth is 4,000 kilometer, radius of the earth is 6,400 kilometer. Okay, you please substitute and you let me know. So what happened? So meanwhile, I'll just quickly show you the quiz. Okay, so what is this quiz? Okay, so the quiz is about something, okay, so that is connected to the next chapter that I'm going to teach. Okay, so what is the next chapter? So till the quiz gets loaded, I'm going to show you the clue for the next chapter. So what is the clue? So this is the clue. So wait for it.